Welcome, everybody. Happy Tuesday afternoon, CES. How you doing? Yeah? And there was grand rejoicing. I'm Bill Briggs. I'm Deloitte's Chief Technology Officer, and we have a phenomenal panel today. I love the title, Intelligence Through Motion, as we talk about AI, physical robotics. And to me, this is the counterpoint to this narrative this last year or two around, are we not seeing the real enterprise value and the impact of AI? And I think it's typically because we talk about the world in these empty rhetoric and headlines, and when we actually talk about real use cases and real application, that's where we're seeing real value today. This isn't in the future. And the fact that it's moving into the physical, digital and physical coming together, and how we're tackling it in very different industries, different applications, the potential is real, and we're just getting started. And you've seen that theme in the last 2 days already. It's only going to continue. And this is going to be an amazing time that we're going to spend 10 minutes or so. Deloitte's done a lot of research in the space. We've invested heavily in the space. Great partners on stage with me in a bit. Talk a little bit about the framing, how we think about it, and then we'll get to the real action where we'll bring some leading voices to make it very, very real. So we're going to awesome action-packed 40 minutes. This first piece I love because the physical AI, physical robotics, the headlines, especially in CES, are in the form factors. And we're going to have different form factors represented today. Clearly, there's a wide continuum. And with that comes the industries they're focused most on and the use cases and impact potential. The other piece of this, which is going to be an equal part of the session today, is what does it take to make all of it real? So we get a lot of, especially at CES, the excitement around the physical form in the hardware itself. Hugely important, great innovators driving that growth, joining us today. And everything that has to happen before and behind the scenes to make it real. And so this view is something that we've created that I love because it basically says, here are the things that have to be true as we talk about making physical robotics real. And the value in the digital twin and simulation and digital assets behind that have their own potential value and impact. And they feed into the closed loop of then using to deploy in the hardware form and the feedback cycle behind it. So if you go top to bottom, this prepare, how do we design, how we think about use cases, applications, the bill of materials have to be in place, and how do we understand how they're going to navigate and how they're going to do their job and make impact, make a difference. The perceive, the sensing, the real time, the big piece of robotics is we have to understand, we have to actually react, we have to take action, and we have to play that back through. Processing, that's the actual sense making, a huge piece of it. And it's the AI and the models, so as we move into world models, and what does it mean? How do we actually put it in place on the edge? Because as we're talking about critical infrastructure in manufacturing floors, supply chains, and hospitals, in self-driving cars, we don't have the luxury of letting it go round trip into the cloud, into the data center. It has to be local because we're talking about milliseconds or less to make decisions and take action. And then how do we use that to make them better over time? Then we have, of course, the things around deployment, so training, deployment, performance, proceeding, and the closed loop reconciliation behind it. I love that this is taking such center stage at CES because historically CES has been consumer, and there is a lot of attention and excitement around the laundry folding robots, the humanoid form factors that will come and have a huge impact. But we're going to have a heavy emphasis on industrial today because that's such a piece of the enterprise value that we're seeing in reality today. This next view, cross-industry. So what are use cases that we're seeing? So a ton happening in supply chain, a ton happening in manufacturing, in hospital systems. So you'll see in the middle here, Moxie and Digit on the top right side. Our panelists will bring that to life. We have a huge bit in surveillance. So drones and autonomous, looking at wire systems, wire lines, utilities, not only understanding where there's potential impact implication today, but understanding looking at every single line, every single bit of foliage and tree and leaf and what might happen with wind systems and predicting where that might actually trigger an outage or maintenance event and doing that before we see real disruption. Security, hospitality, and these are just the beginning. So the key here is going to be trying to translate the hand-waving rhetoric of what could be possible I'm a huge Beast Boys fan. I love the idea, wouldn't it be nice, hope and wish and pray it might come true, into what has to be true to take action, because this isn't about the what, though the technology is really fascinating. It's about the so what, business, enterprise, government impact, and then let's get to the now what of how do we actually invest and take advantage and fully realize the potential. So the overarching theme here is going to be trying to demystify what has to be true and how do we make it incredibly real. There's a great report we published that you can grab if you want. It goes through all this in great detail, the 6 layers of the stack, the use cases, the examples. You're going to see more and more partnering happening before, during, and after. But we don't want to waste a lot of time because this is a rock star panel, and I want to get into it and let the experts tell you exactly what they're seeing. So, without further ado, if I could ask my panelists to come and join me on stage, I will go down. First, we have Andrea Tomaz, the co-founder and CEO of Diligent Robotics. Yes, great applause. We have Deepu Talla, he's the VP and GM of Edge and Robotics at NVIDIA. And we have Pras Pras, I'm sorry, we should have practiced. Say your last name so we don't butcher.
Veligapudi.
Veligapudi, obviously. The Chief Technology Officer of Agility Robotics. Thanks for joining, everyone. What an exciting time. Welcome to CES. I want to start with Deepu. So a ton of the announcements yesterday around everything that NVIDIA is doing in and around physical AI and physical robotics. And Jensen had, I think, 15 different form factors, including Moxie and Digit on the stage with him yesterday, including a cat excavator down to Disney's BDXs, which was a fun. But there's so much happening on the hardware front and so much happening on the software front. What are some of the highlights from your perspective in case people missed it?
Did anybody miss it? If you missed it, please do take a look at it. I think there's 3 main takeaways. The first one, I think as an industry, AI industry, what was surprising last year was the promise and popularity of open models. I mean, now 25% of the world's tokens are being now generated in open models. 80% of the world's startups are using open models. And NVIDIA has now taken on the mantle of doing all of our models open. Open is not just the model weights, but the training data set, all the test scripts, everything. So that's a very important phenomenon that's happening in the industry. The second one he talked about was physical AI, of course, and how fast it's transforming. And within physical AI, we are doing open models there as well. A couple of things that he highlighted. One was for autonomous driving, a model called Alpamayo, which is an end-to-end driving model that's open sourced. And then, of course, for general purpose humanoid robotics, what's called Project Groot. We also have a bunch of models. And then for data generation and simulation, World Foundation model, a model called Cosmos. So that was the second thing he touched about. The third thing, of course, announcing Vera Rubin, which is the follow-on to our Grace Blackwell.
Yeah.
And Vera Rubin's going to be, again, another order of magnitude 10x throughput, and or in other way, 10 times cheaper token.
I don't think anyone missed it, but that's fantastic to underline on. All right, Andre, so Diligent is deployed Moxie. I love the 2025 highlights that you had. So 83,340 miles that Moxie covered last year, over 1,000 units that they're deployed. I'm not sure if everyone knows exactly what Moxie is, so maybe do a beat just to make sure and introduce. But then you were one of the first to actually deploy mobile manipulative robot in a workforce, in a workplace, in a hospital. Talk about what surprised you as you went from concept to getting it deployed onto actual hospital floors.
Yeah, absolutely. So Moxie is a mobile manipulation robot that has, on the bottom half, it's a mobile robot with storage. So it has 3 different drawers, can carry large things, small things from point A to point B in a hospital. And we're doing lab samples, medications, lightweight equipment, supplies. You would be amazed at how many things get run on foot across a hospital. And these are really highly trained nurses, clinicians that are doing that work. And so we are partnering with hospitals to be able to take on some of that menial work. And we've, like you said, traveled more than 80,000 miles doing delivery tasks.
That's a stack. I mean, how many units is deployed? So
we have about almost 100 robots deployed.
Okay.
and they're across more than 25 hospitals in the U.S. and serving over 1,000 different nursing units.
And when you see the video in action, manipulating elevators, I love one of the features is called out to be happily taking selfies with folks. I'm sure that happens quite a bit.
Quite a bit. I mean, so you asked what was the most surprising. I think, my background is robotics and engineering, and we, very carefully said, well, we should go into a semi-structured environment where we think that it's actually possible to, really get robots working today, kind of to your point. And I think what's been surprising, even about a semi-structured environment like hospitals, it's the long tail of variation is vast, and the dynamics that people add to an environment. So robots having to, having to deal with everything that people might do in the environment, that's been the most surprising part.
There's a great quote from the movie Clerks, "This job would be great if it wasn't for the customers."
Exactly.
So Pras, maybe do the same as what the journey you've been on and introduce a bit about Digit, and then also similar challenge in a factory manufacturing floor, semi-structured control. What have you guys found? Talk a little bit where you are in the journey and some of the deployment fun realities of getting it from lab into reality.
Yeah, so at Agility we make Digit, which is a humanoid robot, so 2 arms, 2 legs. We walk around. It is a mobile manipulator as well, and we've been bringing it into manufacturing and logistics environments. We've actually been deployed at some of our customers over a year. At one of our customers, GXO, we've moved over 100,000 totes there for their order fulfillment. And so we've been out in the world and deploying these robots and seeing sort of what happens when you do that. And to Andrea's point, it's really this eye-opening experience of there's the whole part of the problem, which is get the robot working, right?
Yeah.
Get the robot to do the task. And then there's this long tail of all the things that you discover are also important, relevant pieces of making the robot actually function in that environment. Learning about, hey, the floors are actually very dusty in these environments. They're quite a lot more slippery than the lab environment. First shift takes really good care of your robot. Second shift sort of tolerates your robot. Third shift ran into our work cell with a fork truck once.
Intentional or not, we don't know. Litigation still pending.
Unintentional. They were very apologetic about it.
Yeah,
but there's a lot of variability in those processes that you have to tolerate to hit customer KPIs. And in manufacturing and logistics in particular, the markets are very driven by KPIs. They're very driven by, is this process being fulfilled at a rate that's useful to us?
Yeah. And how important for both of your, it's funny, the team I think wanted some fireworks up here. They wanted me to say which is more forgiving, a hospital floor or a warehouse. We're not going to go down that path. We can debate that later. But the importance of having a defined business process that has some benchmark, that's a measurable improvement, if it's patient care, if it's totes being moved within, like that is a part of the KPI to be able to actually point to value and outcome and return. How important is that in both of your worlds?
Sure. So for us, really, that's the metric by which scale is unlocked.
Yeah.
You can deploy into a proof of concept or something like that. A lot of folks are willing to try out a robot and see what happens. But if you really want to keep that robot deployed, if you really want the operations folks to push for adoption in more work cells, in more facilities, you have to show that this is a net benefit to their operations, and that comes from meeting these KPIs. And they don't necessarily care what the exact form factor is.
Sure.
They care that the form factor brings benefits to their particular process. In our case, it's being adaptable to the environments that they're working in, low infrastructure, and ease of deployment. And Andrea, I think you talk a bit about that too.
Yeah, I mean, I think the only difference I would say in hospitals is that it's not necessarily things that they're tracking. Like, there's not necessarily a known quantity of the amount of steps that nurses are taking going to the lab.
Yeah.
It may even be that the leadership at the hospital has an idea that I think my nurses are probably wasting time running things around, but they don't know.
I'm sure it's
how
eye-opening
much
when
it
they
is.
actually
and
see.
so then we're able to show them data and say, hey, here's how many times you would have had a clinician going down to the lab or down to the pharmacy. And so sometimes we're helping them discover the KPIs and then track them, and that's where you uncover the value. And to Pras's point, that's how you get from pilot to deployed.
Perpetual POC and perpetual pilot and the scaled impact. I love it. Okay, so Deepu, from your side, and looking at from the hardware and the platform enablement, how do you get a sense, as you talk to clients, potential customers, when there's organizational readiness to do the hard steps that we're talking about to get it beyond a shiny object deployment and a POC into something that actually is going to potentially scale? Like what?
Yeah. First of all, our job's a little bit easier because we get to work with all of the best roboticists in the world. We're literally working with every robotics company. And what we've learned working on this for over a decade is robotics is a 3-computer problem. You need 3 computers to solve this. Of course, there's the physical computer inside what's called the robot brain, because when you think of a robot, obviously all of us are thinking about the robot itself.
Yeah.
And that's the end destination. But prior to that, you have to train the model. You need large data center. You need lots of data. You need to collect data, and you need to generate the data and train it. And then when you train it, you got to test it before you go and deploy it. And given that there are not that many robots in the world, it's actually virtually impossible to test it in the physical world. So the answer is simulation. So we have another computer for doing the simulation. So we provide these 3 computers, and then we provide all the different workflows and acceleration libraries and models on top of these, whether you're collecting data, or generating data, or you're training, or you're testing, policy evaluation, and then you're runtime deploying. And then what from our vantage point, because we're providing this platform, we get to work with every company working in robotics in some capacity. They might not use everything, but they tend to use at least something from our product. And what we find is, I think the examples that both Pras and Andrea gave, somebody asked me the other day, how do companies work in robotics? I actually think every company is working in robotics, and the reason for that is it's not like you could buy a robot and then just deploy it. The robot needs to be integrated into your existing workflows, and workflows could include other robots. The workflows could include digital AIs increase in the future, and humans, right? So in terms of going to your question of, how do you know it is, you first have to define the use case and the KPIs. And ideally, at this point in time, given the general purpose brain does not truly exist yet. Someday we'll get to that chat GPT moment, hopefully sooner than later, where there's a good enough general purpose robot brain, and then you can specialize into each area. But today, before we get there, the best way to solve that is to find the use case, narrow down the parameters, if you will, a little bit if you can. And that's why, industrial, that's why these environments, enterprise environments kind of make sense, because you don't need 99.109 of accuracy like in a car, or like maybe 99.159 like a surgical robot.
A surgical robot,
you could probably trade off with 99.99 is kind of okay, because you can kind of fence it.
And every engineer in the room knows the difference between 99.99 versus 4 more, but even 99.99 is a hell of a milestone to hit. Have you seen a difference? And I love that you called out at the beginning, it's been 10 years in coming. We act like this is a new development. It's been a lot of research over the years. A difference in who the executive sponsor is, the potential buyer in your clientele customer base. Has that evolved in the last few years, or is that still evolving?
It's certainly involved for us.
Yeah.
I think we have buyers that are really thinking about, I need to be thinking about robotics. I need to be figuring out my strategy.
Yeah.
And if I haven't figured out my strategy on automation and robotics, I'm behind. Versus when we first started Diligent 8 years ago, we were really just getting funneled to kind of the innovation leaders of, let's think about the hospital of the future. This is coming, 15 years from now. But I think, really through the pandemic, we saw a lot of strategy change in terms of automation.
It went from being a great picture to include in a year-end report to something actually embedded in operations.
Like we need this,
Yeah. Praz, you're gonna?
Yeah, similarly, Agility's been around for 10 years. We actually just had our anniversary pass. So the first Agility robots were deployed in universities. I think there's actually still a couple literally running around at Berkeley. And we evolved from there to similarly being an innovation purchase. Hey, let's get this thing, let's put it in a lab, let's try it out. Now we're engaging with the operations folks, right?
Yeah.
We're talking to the folks that are running the facilities. They're the ones interested in making the purchase because they see it not as an experiment of the technology, but as an investment that they're trying to make in their process flow, right? It's a very different demographic, and they're
Yeah.
looking for very different levels of maturity and surety in the technology.
How important is it a willingness to say, we don't just want to take the steps that we traditionally had, maybe a much more focused piece of technology in early stage robotics, or it's a manual task that humans are doing today and just directly replicate it versus how do we actually think outcome back? Like, is that a part of the active, as you're working with clients to actually be bolder and do more and take better advantage, how much does that institutional inertia play into it, of helping inspire them that, hey, this can't just be veneering of what always was, because we might just weaponize inefficiency
Yeah.
in an expensive form factor.
For sure. And I think that's where, for us, it really comes, it's interesting because the Moxie robots, they don't do any person's full job,
Yeah.
right? So we do, as part of the use case design, we have to kind of say, what are the individual parts of this person's workflow or this particular clinical path that makes sense to automate.
Yeah.
And that's the part where it really gets people thinking about, oh, well, why do we do it this way? And then we've been able to have certain clinical workflows around infusion clinics or telebox deliveries or discharge medications. We can show one hospital system like, well, here's how this other hospital system did it. Do you think this would be a good process for you? And you can kind of help bring that automation, can kind of usher in that efficiency.
And work through the multiple stages of change. The first
Yeah.
bristling effect,
Yeah.
well, that's not how we do it. No, that's not it. And all right, Deepa, you mentioned Omniverse and everything that goes into simulation and training. And I mentioned in the upfront, there's also this exhaust of those investments and those assets actually have additional value beyond just the ability to train and deploy in the physical robotics sense. So think about enterprise simulation and planning. How has that evolved? And is it evolved in the way you thought it would?
Yeah, just to step back for a second, I think there's three things that are speeding up the need for adoption and deployment of robotics.
Yeah.
Of course, there's always been labor shortage and dangerous jobs, and that's continuing to become more and more critical. But two other things happened recently. One is on the technology front in the last 12 to 18 months, both with the advent of large language models and taking it into vision language and actions, or generative AI, agentic AI. So that technology now has solved certain problems in other areas that was not solved before. So we can apply that same technology to robotics. So there's a chance
For
of
interaction and
there's a chance of building a general purpose reasoning robot brain. So now suddenly you can see it, the best in the world, from research labs to funding to, you can see all of them are starting to work on robotics problems, right? The other piece of technology that also matured, we've been working on it even longer, is simulation. And it's virtually impossible to build and test robots in the real world. If we did that and we didn't have simulation, I think we're going to take decades, if not century plus, to get it all done. But the problem with simulation is the sim to real gap is sufficiently large that you don't trust the result as to what's happening in simulation. Now the closing the sim to real gap is going to be, I guess we're going to be working on it for the next 20, 30 years for sure. But the good news is we've reached a tipping point where for certain scenarios, it's become good enough. Whether it's physics modeling, whether it's the whole visual fidelity so that you can do sensor modeling and you can use what you test in simulation is going to materialize exactly in the real world. So that's the second reason why there's two technologies going up.
Yeah.
The third one, which happened, is reindustrializing, reshoring, manufacturing. You see lots of new factories, new buildings are being built up, which further, right?
Yeah. Go back to Doe, exasperate the first.
So that's why I think you ask the question of buyers, and it's like you have no choice now.
Yeah.
But to experiment with all of this technology. So now getting back to simulation. So simulation, we are using it for, we see two main reasons, right? Two main tasks, two main problems we're trying to solve. One, of course, is testing in simulation.
Yeah.
Because it's faster, safer, cheaper. And someday we should be able to simulate thousands of times faster than real time, which means you can run many experiments. And it's plus you can run thousands of experiments.
In
or
edge case
millions of
scenarios that would never
edge
be
case
thought- I mean,
scenarios, and you can
have
do
it
all of
Yeah,
that.
yeah.
You can run so many, and just orders of magnitude more in the simulation world, and it's and safe. And the second thing that we're finding in simulation is real world data does not exist for data generation or to train the robot. Now, in the case of ChatGPT and language, most of the best books and the best literature, peer-reviewed, if you ignore the social media crap that's sometimes out there, but most of the data is extremely high-quality refereed data, right? So, and language intent is also captured very well in that. But when it comes to robotics, YouTube video and all that is good, but not still good enough because there's no physics component in it.
Yeah.
We don't know how much pressure there needs to be or how much touch there needs to be. And so this is why the industry is now going back off into, can we use AI to create this synthetic data, which is world foundation models, 3D modeling, physics modeling, in addition to collecting real world data. And that's what we're seeing, like the biggest thing that's happening right now is in the area of simulation, both for data generation and testing.
With characteristics that make it inherently more trustable to be applied and deployed. Well, okay, Press, I was going to ask you, and Deepu hinted on it, the narrative of, well, isn't robotics going to be a job displacement factor versus a lot of the work you're doing is there's jobs that we can't fill today, and how do you see the future of your field evolving with that headline in mind?
It's something that comes up quite a lot when we're
Yeah.
looking at the humanoid space for obvious reasons. You see something that's in the same form factor or generally similar, and you think about job replacement. But I think it's turning out, and Andrea hinted at it earlier, this is more of a job transformation type of revolution. What we're seeing, and I think the way that this will play out, is that we can do pieces of what would be a job role at a facility. We might unload and load a machine that someone's running, but now they don't have to load it with 50-pound metal totes all the time, right?
Yeah.
We can take that one piece out of their operation. There's a lot of activities that are called things like water spider or similar, like multitask jobs. A person is going around doing 5 things or 12 things, and what we can do is take the 4 manual labor activities off of that plate and leave the remaining ones of checking on things or problem solving things, areas where we can kind of upskill the labor force. And so the idea is, let's be able to deploy our humans where they're the most valuable to us and get all of this manual labor, all of this glue automation tasking off of their plates.
Yeah, and I think in both of your worlds, a lot of those specific tasks are the rote repetitive, potentially exhaustive, maybe dangerous tasks, which isn't what folks in their fields went in to focus on anyway. So, Andrea, when we were talking, the spirit of collaboration as you've deployed Moxie into hospital systems and floors, I don't know if it was surprising, but it was encouraging to me. What does that look like, and how do you design your product to help make that what it's become, which is a net positive in most communities?
Yeah. So, I mean, I think we took, the question of, is this robot replacing somebody's job? From the beginning, we were like, we have to make sure that that isn't how the robot's perceived, or we're not going to get anywhere.
Yeah.
And so we really set out, and a lot of our, really early conversations with clients were about, this is collaborative, this is, augmentation of your workforce. And then from the design of the robot itself, we wanted it to feel like a teammate. Like, you wanted it to feel like something that's joining your team. And we always have the introduction of the robot fleet by the chief nursing officer usually,
Okay.
and walks the floor with the robots and introduces the new teammate, Moxie.
Which,
and
as far as
here's
hierarchy
why.
and respect,
Yeah.
that's pretty high on that floor, right?
Yeah, exactly. So,
Yeah.
and then you have the leadership of the hospital saying, this is why we brought these robots here. We're investing in you. We're investing in you spending your time in a better way. And that messaging really sticks. And in places where, that change management isn't set up from the beginning, you see that there's a lot more questioning, and you have to go back and fix that.
Yeah. And we did a study, and it's a broader Deloitte, just trustworthy AI study, but it was basically, what is your trust and enthusiasm level for AI? And it was broken down by where you are in the corporate ladder almost. And so probably not a surprise, 70% of the C-suite said bullish, enthusiastic, high trust, high enthusiasm. It was almost a log scale as you went down closer to frontline, and by the time you got to the entry-level frontline employees, it was 6.7%. So it went from 70 to 6.7. Ironically, those are the folks that have the best understanding of the places of their day-to-day, most ripe for transformation. I'm sure the nurses know where the knuckleheadery is better than the head of nursing on the floor, potentially. Yeah,
and they usually are the ones that get involved with defining the change. Like, so it's often that you have a leader who says, hey, I know we have some inefficiencies here. I'm not going to be the one to solve it. And let's go talk to the frontline nurses and make that happen. So that's the kind of healthiest change that we've seen.
All right, Pras. So let's talk a bit about what keeps you up at night. This is a therapy session piece of the. So you're running a factory that builds robots, you're deploying them, you're maintaining them, and they're at your clients' customers in their critical infrastructure and processes too. So you see the full life cycle within your own walls, and then also as they're deployed in the wild. What's the biggest challenge that doesn't get enough attention?
I think it would have to be safety.
Yeah.
Safety is such a key piece of bringing out this technology in the world because of what the technology can do. We're building systems, and Digit is one example of this. It's built to interact with the environment and move heavy loads, interact in a lot of diverse ways, and that's something that we really haven't had to deal with before in a lot of cases. The safety strategy for many robots historically has been keep them from touching anything.
Right. They're boxed in within very clear. Yep.
Keep them inside of walls.
Yep.
Keep them a foot away from a human. Slow them down if a human gets close, and leave it at that.
Yep.
And that's simply insufficient for this new generation of robots whose primary function is to go out in the world and touch things and move things and exert heavy forces. You know, we're carrying, 30-pound, 50-pound totes around. That requires a very different safety strategy.
In dynamic
and dynamically stabilizing, right?
Yeah.
We're walking around, right?
Yeah.
So you have to think about safety a very different way. So we started an ISO working group to basically define a standard for safety in industrial robots with dynamic stability. But you really have to develop this new technology in the safety space to think about how do I now actively make safety decisions? I can't just create a force field around this robot and leave it at that. I have to think about, am I surrounded by people or walls or totes? How is my robot going to fail if it has some sort of joint failure? What is it going to do? I can't simply lock all of the joints when you have a humanoid robot. So that's the thing that I think is critical for being able to scale and warrants a lot of attention. We've invested heavily in it, certainly, but I think that will be the big piece that needs to fall into place that'll unlock humanoid scaling.
Yeah, and Deepu, you mentioned it in the training, testing, deployment, in the models that you're building and helping bring to life the broader industry. There's also the layer of cyber, because we're talking about now critical infrastructure in places where we can't have bad actors coming in. So how has that been a piece of the broader NVIDIA strategy and how you think about the product roadmap, the platform roadmap?
Yeah, so both safety and cyber security have to be designed with every process that we put in place, right? So when let's start with safety, to just expand on what Pras mentioned. So safety has to be the full layer across the stack, from the chips need to have, in the case of, we can borrow some of the principles from automotive, where the chips are certified ASIL-B or ASIL-D, depending on that. And then you add next level, one level higher at the system level, you add safety microcontrollers. So you can expect the same thing to happen in humanoid robots and other robots, where highly likely there are going to be tens of processors in the system. There'll be a big brain, maybe an NVIDIA brain, NVIDIA-powered brain. But then you're going to have lots of actuations that are going to happen, and you're going to have regional microcontrollers. So there's going to be a lot of compute elements, right? And then safety needs to be designed into all of those. And then one click above that will be the core level software. Your operating system needs to be safety certified. Your models, algorithms need to be safety certified. and then eventually the applications themselves, and then all of this needs to be independently certified, validated by, right?
Yeah.
And then when you come to security, the same thing. The good news about cybersecurity is, of course, it's a problem for every industry. So the techniques that you use for data center or your mobile is similar, that you can use the same techniques for robots. Now, except in the case of robots, the potential for misuse is a little bit higher because there's actuation, there's physical touching that's going to happen, right? And this is why robots will not go into general purpose robots, will not go into homes and everywhere until it's deemed safe and secure. So this is a journey that the whole industry we need to be on. Yeah. And I think the good news is it's not relegated to like an afterthought. I mean, there are multiple safety security committees in robotics that are leveraging from automotive and starting to work on it.
Yeah, because in any of those use cases, it has to be fault expectant, not fault tolerant. And the same, I do like harkening back to the same principles we've always had of at rest and in use and in flight. Like that still applies, but at a different scale. All right, Andrea, the collaboration point, I love the idea of the head RN is the one doing the introduction. I had a panel earlier, we were talking about culture, community, learning development of the human workforce as they're learning to collaborate with the new folks, co-workers with them. And then there's also this ... into, should we be talking more about what is the HR equivalent for a robot as it joins the workforce? Any thoughts on...
Yeah, I love that thought. So I think that it's definitely a learning experience for the workforce, and there's a lot of turnover in nursing in particular, right? So you'll have new people join the team and they kind of have to learn like from their colleagues, like, okay, what do we use this robot for? Oh, I get it. This is what the robot
right.
does. And so, we even have, in some cases, we'll set up like a super user group. So this is, they wear a pin, and if you have questions about this robot, here you can have it go.
Is it a Moxie pin?
It's a Moxie pin,
yeah,
of course.
Nice. Yeah.
But I think that's, in terms of product roadmap and how you think about it, having the robots be able to do more have more self-explanatory, ask me about what I do kind of interactions. In terms of how I think that the workforce design certainly is going to have to think about automation plugging into that. Yeah. So it's like, I think HR is absolutely going to have to be
increasing reality, and we see some, Moderna's been public about their chief HR officer equivalent. Tracy is now the chief people and digital technology. The IT and HR came together because of this. Okay, we're going to play future. This is going to be speed date future. We're at CES, not in 5 years or 10 years, but next year. Look at 28, maybe one bold prediction. So 1 or 2 years, you can choose, Praz. I'm going to give you a little bit of window. It's like Price is Right game. What's going to be the headline? What's the big takeaway from CES 1 or 2 years out? Praz, I'll start with you.
Well, we'll be releasing a new version of Robot.
I love that.
So
okay.
hopefully that'll be maybe one of them.
Yeah. Okay.
But with functional safety on board and with the ability to safely navigate, we're really trying to tackle a lot of these pieces right now. And so my hope is that in a year, we'll be talking about that new level of capability in robotics as a foregone conclusion, not a hypothetical.
Okay, Deepu, this is safe harbor. We're not going to shape and make markets here, so you don't have to do anything improper on describing roadmap. But what do you think, broad theme?
I think there's one type of robot that people don't talk about as much or think of it as a robot. We think of it as an outside-in robot. Like cameras and sensors are in a hospital, in a factory, and they're watching things that move. And those will be the first safety deployments that will actually happen because the infrastructure is already existing. It's kind of like air traffic control. It's kind of like GPS information that's coming to you. So those deployments, I believe, will happen in the next 1 or 2 years to help all the individual robots.
And you'll feed the data into to have a bigger corpus to be able to help us learn to train, deliver. Okay, Andrea, last thought.
So I'll say that I think that we have a lot of companies, and Deepu talked about a few of them, working towards the general purpose. But I think that over the next couple of years, we're going to see even people that maybe are out working on a general purpose robot platform or foundation model scoping that down to do something in a very particular set of skills in a very particular place. So I think that in the next 2 years, we're going to see more operationalizing of these physical AI advancements.
Yeah, focused with very specific functions, sector, subsector application.
Yeah,
Okay.
we got to do something first.
I love
People are
it.
going to pick.
All right, so quick plug. There's 3 more sessions on physical AI, physical robotics from Deloitte in the next day or 2, so check that out if you want to learn more. Please join me in a huge thanks to our amazing panel.